Hello, everybody. I've gotten an email or two about people wanting me to work some questions that are in section 9.2 of Unit 4. So I'm going to work a few of these problems for you. Again, this is in section 9.2. The question says Phyllis, a college business student, wants to show how many students in her class study for less than 20 hours per week. Um, Past data reveals that the hours college students study per week has a mean of 29 with a standard deviation of 9 hours. The normal distribution for the population is shown by the dotted line. She plans to take a random sample of 36 such college students and will calculate mean hours studying to compare to the known hours studying. And then the actual question part of this one is compute the mean and the standard deviation of the sampling distribution of the sample means for a sample size of 36. Round your answer to the nearest tenth. Okay, so here's some things that we know. In chapter 9, the mean mu sub x bar, which is the mean of the sampling distribution, will be equal to mu. So you don't really have to do anything. Just pick out what the mean is. In this case, they tell us that she has a mean of 29. Okay, so for this problem, mu equals 29. Okay, now we want to compute the standard deviation. Now, the standard deviation for a distribution of sample means is equal to sigma divided by the square root of n. Okay. In this problem, we have a standard deviation of 9 and a sample size of 36. Okay. So, sigma in this case is equal to 9, and sample size would be the square root of 36. Okay, so that would give us the square root of 36 is 6, so this is just 9 over 6, which would be 3 over 2. Rounded to the nearest tenth, this would be 1.5. Okay, so then you just go back to the problem and you show that on the sliders below. Okay, simple enough. Okay, here's another problem that we have. It says the lengths of fingernails of all people in a country are normally distributed with a mean of 1 centimeter and a standard deviation of 0.2 centimeters. What is the probability that a sample of 5 people with a mean lengths is between 0.9 centimeters and 0.12 centimeters? Do not write the probability in terms of a percentage. Round your answer to 2 decimal places. So let's write down what we know here. Okay. Let me get rid of some of this here. Wow. Might have been easier just to start another page, huh? Okay. We know in this problem that mean of 1, so we know mu is going to be equal to 1. Oops. We know mu is going to be equal to 1. We have a standard deviation of 0.2 centimeters. So we know that sigma is going to be equal to 0.2. Um, we know that sample size is 5. So in this case, n is equal to 5. Okay. And we have two x values in this one. We have 0.9 and 1.2 centimeters. So we're looking for the probability that x is between 0.9 and 1.2. centimeters. Okay. So our sigma for the sampling distribution in this case again would be sigma divided by the square root of n. So this is 0.2 divided by the square root of 5. Now, to make my problems more accurate, I'm going to leave that like it is instead of trying to calculate that out. Okay. So this is what we're looking for down here between 0.9 and 1.2. So if we sketch our distribution, okay, we know that 1 is in the middle, and we're looking for 0.9 to 1.2. Okay, we're looking at this region right here. Okay, so we can treat this just like we did the normal distribution stuff in Chapter 8. So if I go to my calculator here, I can do second distribution, normal CDF. In this case, my lower bound would be 0.9. My upper bound is going to be 1.2. Sigma mu is equal to, mu is equal to 1. Sigma in this particular problem would be, again, this is sigma divided by the square root of n is your standard deviation. So we're going to have 0.2 divided by the square root of 5, your sample size. So 0.2 divided by the square root of 5. Okay. And that's what we have so far. Lower bound, upper bound, mean, standard deviation. Okay, so let's see. In this problem, they want us to round to 2 decimal places. So 2 decimal places in this case would be 0.86. Okay, so this would be equal to 0.86. And if we look at the problem, there you go, 0.86. Okay. I think we have time for one more problem in this video, and then in the next one I'll do some proportion problems. Okay, the ones that you have in there that are dealing with all these percents. The body temperature of all mosquitoes in a county have a mean of 63 degrees Fahrenheit and a standard deviation of 14 degrees Fahrenheit. What is the probability that a sample of 49 mosquitoes have a body temperature between 59 and 67 degrees Fahrenheit? Assume the underlying distribution is normal. Okay, so here we go. Let's write down what we know. We know mu, we know that mu will be equal to 63 degrees Fahrenheit. Okay. We need the standard deviation, we need n, and then we need our x values. But here, let's go back and see. Standard deviation of 14 degrees. Okay, and we need a sample size here. Sample size of 49. Okay. So we have a sample size of 49. And the problem is asking us between 59 and 67. 59 and 67. Okay. So the probability that X is between 59 and 67. Okay. So, we can sketch our distribution here. Whoa, that's terrible. In the center, we've got 63, which is our mean. We know 69 is going to be on this side. We know 59 is going to be on this side. So it's again one of these type of problems where the shaded area you're looking for is in here. Okay. And we can pretty much go to the calculator. Now remember, your standard deviation for the sampling distribution here will be 14 divided by your sample size, the square root of your sample size, which would be 49. So when you go to the calculator, that's what you're going to be putting in for the standard deviation. So going to the calculator here. Let's see, second distribution, normal CDF. My lower bound in this case is 59. My upper bound is 67. My mean is 63. And my standard deviation is going to be 14 divided by the square root of 49, which is 7. So that'll be 2. And enter. And enter. And let's see, let's look at the problem here. They say round your answer to 2 decimal places. So 0.95. Okay. And if we go back to the problem, there's your 0.95, the correct answer right there. Okay. All right, well, I hope this helped. And again, in the next video, I'm going to talk about proportions. We're going to do those problems that have all the percentages in them. Hope everybody's doing well, and we'll talk to you soon.